Hi guys, today's lesson is really important. We're going to be looking at maxima and minima, and really we're going to be taking calculus to the next step. We're going to be going, well, now that we know how to do calculus, what are we going to use it for? And what we're going to use it for is finding these maximums and minimums. And it's a really important topic because it's how calculus is used in the world so much. We want to find these maxima and minima because it's really important. You know, at the moment they're trying to find out when will this virus peak, and so what will be the day on which the highest number of new infections occur, and then it starts to decline again. That's really important. Share prices, we want to know what the minimum share price is going to be so that we can buy at that point. So you can see sort of the importance of this. And so we're going to be taking these ideas that we've learnt with calculus and in yesterday's lesson with sign diagrams, and we're going to be putting this all together. So let's have a look at this diagram here on the page. You can see that there's a maxima at point B and a minima at point C. Now, we don't just call them maxima and minima, we give them special names. So point B we say is a local maximum, because there are actually some points on the graph that are bigger than it. So it's a bit like a big fish in a small pond. You know, you think you're big, but you're not that big. And so you can see that point D is actually higher than point B, and there are a few other ones before that. So point D we call a global maxima because the biggest point anywhere on that curve, whereas point B is this local maxima. And likewise for A and C, global minima, and local minima. Okay, so let's figure out how we can find these. Now, to begin with, I just want to add a few things to this curve, and it helps that you've been doing these sign diagrams yesterday. So we can see from A to B that the graph is increasing, so we know it's got a positive gradient along all of these points, and I'm just putting pluses anywhere to show that. And over here it's got a negative gradient and then a positive gradient as well over here. But what's important are these points B and C, where in fact the gradient of the tangent is 0. So I'm just going to put some zeros here. And so at maxima and minima, we always get this thing happening where the gradient of the tangent is 0. So if we want to find these maxima and minima, we want to find where is the gradient of the tangent 0, or where is f dashed of x 0. Okay, so let's take some of these ideas. So we could easily draw a sign diagram from this that I've put the pluses and minuses there. So let's just do that. Ooh, let's drag this down a bit. Okay, let's put that over here. Here's my wiggly sign diagram. Sorry, it's going to be pretty bad. We've got these 2 points at A and C, so -2 and +2. Over here it's positive. Over here it's negative, and over here it's positive. And so from our sign diagram, we're able to work backwards and see a little bit about the graph. So we can see it goes up here, then down here, then up again. Okay. Now what I want you to notice is that from the pluses here to the minuses, it's going up then coming down. Now, any maxima is going to have this same property, that it's going from a positive gradient to a negative gradient. And likewise, a minima is going to go from a negative gradient to a positive gradient. So in your books, you'll see this table here. And it's just explaining to you that you've got if it goes from positive to negative, then it's a maximum. If it goes from a negative to a positive, it's a minimum. And we're going to see these strange things called stationary points of inflection. So these points of inflection, it kind of looks like it's going to be a maximum or a minimum. It sort of tails off a bit, then it decides, no, I'm going to keep going up or keep going down. So we'll see a bit more of them as we go along. Okay, so let's go through this as an example and see how we go. All right. So here's our problem for the curve, and sorry, it cut off a tiny bit. Y equals x squared minus 6x plus 3. We're going to firstly find the gradient function, and you're going to have to excuse my writing here. Okay, So finding the gradient function y dashed is going to equal, so differentiating that 2x, this is tricky, minus 6. Okay, so I found the gradient function. That was nice and easy. Sketch the sign diagram. Well, for the sign diagram, do you remember that the important thing was finding where y dashed equals 0? Because once we've got those points, we can find either side of them. Okay, so if y dashed equals 0, then 2x minus 6 equals 0. You're going to have to listen to me because I don't want to write all of this. 2x minus 6 equals 0, therefore 2x equals 6, therefore x equals 3. X equals 3. Okay, so I've skipped a bit of writing there, but hopefully you follow. So I've found now this, what we're going to call critical value, and we'll put this on our number line. Ooh, wiggly, wiggly, number line. Okay, 3. So now we want to go, what's the gradient on either side of 3? So I'm going to test some values. I can choose any number that's less than 3. I'm going to choose 0 because it's a nice easy number to plug in here. So this number line's for y dash, so I'm just going to write y dashed here to remind myself what it's for. So putting in x equals 0, I get 2 lots of 0 minus 6, which is a negative number, so I'm going to write a negative over here. And a number that's bigger than 3, say 5. 2 lots of 5 is 10, minus 6 is 4, which is a positive number. So from my sign diagram, I can see that it's got a negative slope over here and a positive slope over here. And what we're going to do often is we're just going to draw a little diagram to show this. So a negative slope goes down and a positive slope goes up. So what sort of stationary point do you think we've got here? If it goes down then comes up, well, by drawing this nice little sketch in red, I'm able to see that it's a minimum. I don't need to remember that table that I showed you on the previous page. So I know that at x equals 3, I've got a minimum. So from this sign diagram, I've already found the location. I found it's when x equals 3. But when x equals 3, so x equals 3, we need to know what's the y value at this point. So I'm going to put x equals 3 in, but I'm not going to put it in here, am I? It doesn't go in here, that's y dashed. If I want a y value, I want an equation with a y in it, right? So I've got to look back here at this one at the start. So I'm going to put x equals 3 in there, and I'm not going to write it all down. I get y equals, what do we get? 9 minus 18 plus 3. 9 minus 18, negative 9 plus 3 is negative 6. So I've got the location of my stationary point. It's at 3, negative 6. The nature of the stationary point is a minimum, and I could sketch my curve. Excuse me, it's going to be very simple. It's a parabola, and I could put in this point, and okay, let's try and write it. 3, negative 6. Okay, there we go. Ooh. Sal Khan, look out, here I come. Okay, lastly, let's look at this example here from the textbook. Find and classify all stationary points of f of x equals blah. Okay, if we want to know about this one, well, we've firstly got to differentiate. But do you see when we differentiate there, we get this thing here, which is a quadratic. And our quadratic, we know how to factorise. So I'd take a few steps, we'd take out a common factor, then we factorise using PSF, and we get this equation here. Okay, so from this equation, we set it equal to 0, and we say, where are these critical values? So when would it equal 0? And we can figure out that it equals 0 when x equals 3, or when x equals negative 1. And we put this on our number line. Now with that number line, I want you to ignore the red line for a second. Think of it as not being there. Okay, so we now sub in some values. We sub in a value that's less than negative 1, say negative 2. And I'm going to put it into this factored form because it's easier. 3 lots of negative 2 take away 3, that's negative 5. Negative 2 plus 1, that's negative 1. We've got a positive number times a negative number times a negative number. Negative times negative is positive, times positive again is positive. So I can put this plus here. Now we test a value between -1 and 3. So say 0. 3 times a negative number times a positive number. Positive, negative, positive. We're going to get a negative answer. So we don't need to figure out the exact number answers. We can just plug in values and see what sort of answer we're getting. And lastly, over here we get pluses, and we'll just assume that they're correct. So once we've got this plus, minus, and plus, we can draw in this red squiggly line, and I would have done it more with straight lines and pointies because I don't really know exactly what it looks like, but they've done a nice curve there, so great. And now that you've got that, you can figure out that there's a local maximum because it goes up then comes down at x equals -1, and a local minimum at x equals 3 because it goes down then comes up. And we can figure out the y values by plugging it back into not this equation, into the original equation. So you've got to be careful about that. Okay, I hope this helps, and let me know if you need any more help. Okay, see you later.